Okay, so now we are going to do a numerical example of a second price common value auction. Again, we suppose that there are two firms or two players bidding. For each player, the signal is generated from a uniform distribution between 0 and 100. VI, which is valuation, is going to be TI plus TJ divided by 2, so your own signal plus 1/2 of whatever the other player's signal is. And we want to show that VI, which is your bid, is going to be 1.5 times TI, and that is a Nash equilibrium. If player 2 plays that, then player 1 would best respond by playing that, and if player 1 plays that, then player 2 would best respond by playing that. That's what we want to show. And again, we use the same mechanism we always do. We assume that player 2 plays that, we look at player 1's payoff function, and then using first order conditions, we show that player 1 would best respond by playing the same function. Okay. So suppose player 2 plays this, then the likelihood that player 1 wins is equal to the likelihood that B1 is greater than 1.5 times T2, which is the same as the likelihood that T2 is less than 2/3 B1, which, because T2 is generated from a uniform distribution between 0 and 100, equals 2 divided by 300 times B1. The expected value of T2, given that B1 wins, is going to be 1/3 of B1, because T2 is a uniformly distributed number. If it's going to lie between 0 and 2/3 of B1, here, 0 and 2/3 of B1, it will take the middlemost value. Its expected value will be equal to 1/2 of that extreme. It's going to be equal to 1/2 of this 2/3 of B1. The expected value of B2, given that P1 wins, is going to be basically 1.5 times T2, and T2 is 1/3 of B1, so that's just 1/2 of B1. The expected payoff for player 1 is therefore going to be T1 plus, this is T2 divided by 2, T2 is 1/3 of B1, minus B1 divided by 2, which is the expected amount that player 1 would have to pay to get the product, times the likelihood that player 1 wins, which here is 2 divided by 300 times B1. And again, the first order conditions will give us that T1 equals 2/3 B1, or B1 equals 1.5 times T1. And by symmetry, if player 1 best responds to player 2 playing this strategy by playing this strategy, then player 2 would best respond to player 1 playing this strategy by playing that strategy. And so we've shown that that strategy is a Nash equilibrium.